good to go here? How's the volume out there? Is it okay? All right. Good. Hi, my name is Bruce Johnson. Hello. So yesterday I ran in late to the deferred binding talk and explained how I was going to violate every rule of public speaking. This time I'm only going to violate the one about rehearsing. I haven't rehearsed this one either, but it went well yesterday, I think, so we'll just see how this goes. And again, as with yesterday, if I say something that makes no sense at all, please just raise your hand and tell me that I'm being incoherent, because this is some fairly technical stuff, and I want it to be really clear because it's really cool. Okay. There is sometimes a misunderstanding about GWT. Because you only have a short amount of time to get somebody's attention and explain what GWT is all about. The truth is it's a really very comprehensive, large set of tools and libraries. But what we show is a cool-looking desktop-like Ajax application, right? So that gets people's attention. Then you explain the whole compiling Java into JavaScript story, and then they sort of get a feel for it. But what people misunderstand, it's basically because they assume that this is true, is that they assume that GWT has to take over the entire page somehow, as if it's some sort of walled garden of abstraction. You have to either use GWT or JavaScript, and that we're somehow very hostile towards JavaScript. None of those is true at all. GWT is nothing if not pragmatic, and we would never be so presumptuous as to expect people to rewrite their applications in order to benefit from GWT. That would be stupid. So from the very beginning, interop with existing technologies and the evolution of legacy applications, or, they don't even qualify as legacy, just applications that use other technologies, right, should also be able to benefit from GWT. It's in our charter document. These are two design axioms that we refer to all the time. The big pieces must be independently useful. So I should be able to use RPC and not use any UI at all. Or I should be able to use internationalization and not use any widgets. I should be able to use widgets and not use RPC. You don't want to tie all those things together. You want to be able to only pay for what you actually use. So one of the specific points we made was that widget classes should be available in GWT, but not required. GWT has libraries, but it itself is not its libraries. It's really the compiler, the hosted mode debugging, and all that. That's what GWT fundamentally is. So we said the widget classes should be available but not required. You should be able to code directly at the DOM layer if you're already familiar with the DOM, without having to suffer these larger, more expensive abstractions. If you want to do something simple, why use a very complex abstraction to accomplish it? But that wasn't particularly true that it was easy to do until WIT 1.5, and that's what I'm talking about here today. Okay, what do you get in 1.5 regarding DOM programming? There is a full Java client-side DOM API now. It's in its own new top-level package, com Google GWT DOM client. It is almost directly based on the W3C standard bindings for modeling the HTML DOM as a set of Java classes. We think it's pretty elegant. You can decide for yourself when you look at the code, but it's certainly more convenient than it was in GWT 1.4 and earlier. It's optimal, and I hope to show you that ad nauseum. And importantly, this is a cross-browser DOM, so you can get all the elegance and optimal performance and still just write one code base generally. So the Java source looks nice, surprisingly rocking, in fact. The compiled JavaScript, we feel, is surprisingly rocking. And there's one more surprisingly rocking thing that I'm going to save until later. Okay, so first of all, part one, you do less of the yucky old DOM programming that you had to do in 1.4. If you use GWT 1.4 for DOM programming, that you will recognize this sort of pattern. There was exactly one type called element, and it was opaque. I mean, it could be a div element, it could be a button element. All you got was element. And that element class did not have methods on it. What you wanted to say was element.setAttribute or element.appendChild. But in fact, what you had to say instead was dom.setAttribute. whatever. There was this big monolithic DOM class that had a bunch of static methods on it. So it felt a lot less like object-oriented programming and a lot more like kind of clumsy C-style programming. The reason we had to do it that way prior to 1.5 was that was the only way that we could provide a decent cross-browser DOM that the compiler could optimize very, very deeply. So GWT, we don't ship anything unless it's affordable for you to use. And so we had to design the API in a way that could be optimized. That's why it was the way that it was. It's not that we liked that API. It's just, as a practical matter, it had to work that way. So in this code example, we've got all the ugliness I was referring to. dom.createTr, dom.appendChild, table comma tr, dom.set inner text, blah, blah, blah. Okay, so that's not really what you'd want to see. Using the new DOM classes, you can write the code at the bottom. I have more strongly typed classes for all the various DOM elements. I've got a table element here. I can say document.createTableElement. I have a table row that has a method table.insertRow. I have table cell elements modeled explicitly. And I can finally say things like td.setInnerText. So that is... in the abstract here, that may not make much of a difference, or it may, depending on your tolerance for coding style. But in practice, across a really large code base, this really makes your DOM programming a lot more convenient and a lot more elegant looking. Now, why is it convenient? We'll come back to that, but you can already see the idea of having more strongly typed element types gives you the opportunity to catch more errors at compile time. So I won't inadvertently try to insert a table row into a div where that's not legal, right? You can see how the type system starts to give you an advantage as you're writing your code. The other thing that would typically happen prior to 1.5 is you have to use JSNI. JSNI is also, I think, further proof of how much we mean it when we say GWT is not a walled garden of abstraction. JSNI is the JavaScript Native Interface. And it's a play on JNI, the Java Native Interface. You can, in GWT, you can have a Java method that's labeled native, and you can specify its body, its implementation, using a special comment block which contains handwritten JavaScript. And the compiler automatically knew how to, let you call that from Java, and it knew how to bind the parameter names into your JavaScript code and so on. But because there was a limited DOM API, it encouraged people to use JSNI relatively more often if they were doing some heavy lifting. But as soon as you switch over into the JavaScript mode, you don't get code completion, you don't get static type checking, and all the other good stuff, the whole point of GWT. So we saw that was a bad thing. I also have to admit that in creating this sample code here, I found a bug in our own library in the element to string method here. Do you see that line? It says bug. That the variable outer there, I forgot to put a var in front of it. Actually, I didn't write this bug. Somebody else did. I forgot to put. They forgot to put var in front of it. So it's a global, because if you don't declare something with var, making it a local, it is implicitly a global. And so if this thing were to inadvertently recurse or something, or if an event handler were to fire and read this variable called outer, or if someone else were to specify outer at some other time in some totally other context, we get very unpredictable behavior. So it was a bug that's been there from the beginning, and I just realized this the other day. Let's contrast this with how it's written in 1.5. So first of all, notice it's not native anymore. It is almost line for line identical. Just let's compare the lines. Okay, we have the variable temp, but it now has a type. I write lm.cloneNode is the exact same thing. I do a .cast here on the first line. I'll come back to why you have to do that. Then the next line is tempdiv equals .createElement, and so on and so forth. Do you see these are like one-to-one correspondence between the JavaScript code that we'd have written and the Java code? But when I was writing this Java code, I got code completion, and I could do, in Eclipse it's F3, which is jump to the declaration of this method or whatever. So I get all the nice capabilities of my IDE. Big step forward. So let's look at some of the classes specifically. If you're familiar with the normal browser DOM, then this really won't be a surprise to you. But the fact that these things are now in GWT, it should make you happy, hopefully. So you've got methods like append child, clone node, get child nodes, all the good methods that you would expect to see. All right. Element has all the good stuff you'd want to see there too. Get ID, set ID, set style. Get style is important. I can actually get the style object associated with an element and then call methods on it. So I could say element.getStyle.setProperty, which is a much nicer way of interacting than it used to be. DOM.setStyleAttribute, where you had to specify the element as one of the arguments, which itself was probably a call to DOM.getChild. It got ugly quickly. So let's take a look at a subclass of element. So we've got, to go back here, node extends JavaScriptObject. This is the use of a new technique in 1.5. Prior to 1.5, you couldn't extend JavaScriptObject. Element extends node. So we're getting inheritance as well. So then we've gone even more specific, and we've got a text area element, which extends element, right? And it adds all these things that are unique to the text area subclass. Text area has a concept of the number of rows in the text area, the number of columns, for example. Those methods make sense on text area element. They don't make sense on element per se. So it's where you're really benefiting from the class hierarchy of Java here. So again, let's talk about tools and why tools are good. Text area element has about 100 methods when you add up all the ones that it's inherited. That's a lot of stuff to sort through. And it's really nice to be able to hit control space and see what the relevant ones are. But also, now that you're writing code in Java again instead of JavaScript, I can do really neat things like refactoring. Like I can take a run of DOM code that's written using the new DOM API, select it, and then if you've seen extract method, have you seen this refactoring? You just say extract method, and then it'll take all those statements out and create a method wrapper around it, and you can really easily take advantage of refactoring capabilities of your IDE. That's something you couldn't really do with JSNI, but you can do now. Even more cool but sort of subtle point is the debuggability of this sort of code. These are really fine-grained methods, right? Set inner text, set attribute, append child. There's a very low-level one-to-one correspondence between the Java method and the JavaScript that implements that method. This is exactly what SWT does. If you've ever looked at that, it's a native, it's a Java windowing toolkit that's used in Eclipse. And their observation was that you can either have very high-level methods that are native methods that once you call the method, it does a lot of stuff in native code. In other words, you kind of minimize the native surface area that's exposed into Java. Or you can do the exact opposite, and you can have a very minimalistic binding so that any one statement in JavaScript, any one method call, has a one-liner native implementation. And their observation was that the latter is actually much better because then there's nothing that can really go wrong in the translation. You've got good debugging tools in Java. Native code is a lot more complicated to use GDB and all that to debug it. So if you make the binding sufficiently trivial, stepping through the Java code is just as good as stepping through the native code. And if you contrast that with the other approach where one Java native method call does a lot in native code, then you really have to have both a C++ debugger and a Java debugger. So by borrowing that idea with having low-level but simple methods, it allows you to leverage the strength of your Java debugger all the more. And that's kind of a good principle because what I'm going to be talking about later is how you'll be using some of these same techniques to build your own APIs, and I suggest that you consider thinking about it the same sort of way. The hierarchy looks pretty much like you'd expect. You've got JavaScript object at the top. You've got a node class whose descendants include document, text nodes, and element, and then element has a whole bunch of classes underneath it. I mean, a whole bunch, like, I don't know. Does anybody know? 80? Something like that? 60? A lot of different classes. In fact, there are so many more HTML elements than I ever even knew existed until we did this. And then some more interesting things happen. When I say get child nodes, for example, that actually returns a structure that's a list. And so we had to model that as well. So I can return a node list. But this is Java, and we want to use generics, right? So we're able to model it to be a node list of type T, where depending upon the nature of the parent, it can give you a more specific generic type, which is really nice. And then there's the style element, which I mentioned before. And having that broken out separately can lead to nicer code. Okay. So if you look back on our interaction with the developer forum list over the last year and a half, you'll see a bunch of times people say, you guys are so dumb. You put these methods on this dumb DOM class, and they're all static. It's so obvious that you should just add methods to element and create a bunch of element subclasses and all that. And we said, no, that's a bad idea. That's a bad idea for a year and a half. And it was a bad idea because at the time, we couldn't eliminate all of the overhead associated with that. In other words, we would have had to create sort of a wrapper object, which would require extra RAM, and it would require extra hops through the code because we weren't doing as much inlining at the time. As soon as we proved to ourselves that there is genuinely no additional overhead, that is when we decided that this made sense and it was affordable. So you can switch to this model and get no overhead. Let me show you an example, and I have an even more elaborate example in a second. Take a look at this. S equals table.getRows.getItem.getCells.getItem.getEnterText. It's a little verbose, but it's still nice, typical Java code. It's very clear what it's doing. That seems kind of heavy potentially, but I'll show you what the compiler produces for this. This is JavaScript on the bottom. In other words, it produces the code that you would have written by hand. Well, in fact, you wouldn't have written this by hand, right? You would have wanted to write this by hand. But if you went to the deferred binding talk I did yesterday, and if you didn't, check it out on YouTube, you can't write code like this by hand everywhere because not every browser gives you the exact same set of methods or whatever. They don't behave consistently. So you inevitably have to abstract this out one level if you're writing the code by hand. So it probably wouldn't look like this. It probably would look like some set of function calls. But function calls in JavaScript have overhead at runtime. In other words, we're really proud to say that the DOM API that we have now is both elegant and it produces better code than you might typically write by hand, even if you're coding against it. It's like a nice JavaScript library. So we want you to feel that it is affordable. Actually, so before I jump to that, let me show you an example here. How's the font size on this one? Small? I can do something about that. Say when. Okay. This is a nifty little, it's not exactly an Easter egg because it's only cute if you're a compiler geek, but it's certainly cool. I want to show you what happens as the compiler does its magic, okay? So this is an on-module load. If you've written Git code, you've probably written about 100 of these. We instantiate a button, and this isn't exactly the way that you would write it. It's been processed just a tiny bit already. And I write button.setText woot, okay? So what does the compiler do? First thing it does is it finds things that are effectively final, variables that never change. It marks those as final so that it can be sure that the identity is stable and it hasn't been aliased. Okay. Next pass is it rewrites the call sites. And what it does at that point is it recognizes that these types are actually concretely known. Yesterday in the deferred binding talk, I talked about monolithic compilation and why we don't support dynamic loading of classes. It's because if you know the full set of types, you know which types aren't extended and aren't subclassed. So consequently, you know where polymorphism isn't necessary. So I can write this setText call is actually now a static call. It was rewritten from polymorphic to static. And so instead of b.setText, it's a call to a static method where b is an argument. Okay. Next step. Yep. We're on dead code visitor. What's that? Is there any problem? Okay. Then the next step, and I honestly can't tell you exactly what dead code visitor is doing right here. Normally, it would if there are things that need to be removed, it would remove them. In this case, I think what it's doing is it adds an extra layer of casting here because it rewrites the call to the button, which is a widget that contains an element, so it devirtualizes that call, and you can see the UI object.getElement, it's a static call. I promise this is going to have a payoff at the end. Then we do the inlining visitor here, right? And we inline at one level, where that was b.getElement, or it was button.getElement. It's now just b that's been cast. And then we reference the element field off of it. So we inline a field reference. All right. Next pass, we do some more dead code elimination, which gets rid of one of the spurious casts there. And we're calling the setInnerText method. Now, we tighten the types a little bit. We go on and do another round of inlining here. And so now we see that the reference to the DOM impl got replaced with a more concrete version for IE6. This is the IE6 permutation we're looking at. So it's calling IE6's setInnerText method. Then we keep going, get rid of some more casts, we tighten types again, we collapse the catch blocks. I'm not sure why we do that, but we keep going, and at the end of the day, we end up with some script that looks like this, but we can do even better. Thank you, Bob Varder, for writing a JSNI inliner. So at the end, we end up with this code right here. And so that's the pivotal line is this one. So what was a polymorph? Oh, sorry. Oh yeah, let me do that. I can't really see that screen. So that right there is the magic code. So what started out as a call to the setText method on a button widget, which was polymorphic, which required us to get an element indirectly that's associated with the widget, becomes something that honestly is not the JavaScript code that you would have written by hand. If you look at any JavaScript library that has the notion of a widget abstraction, inevitably you're one layer removed, right, from the underlying DOM items. In this case, you're coding in a way that does keep you removed from the underlying DOM, but the compiler makes all the interstitial stuff go away so that the code that runs, it's as if you were insane and wrote all this stuff, by hand. Does that make sense? Okay. That's the last time I'll ever ask you to look at all the steps of the compiler again, I promise. Hooray. All right. Now, we had to make a tough judgment call. We knew that this would be a nice API library for the DOM, but we already had a type called element in user.client, and so we had to make a decision. Do we name the one that's in the DOM package something other than element? I mean, do we synthesize a new name? Do we call it abstract element or something like that? Well, we didn't want to do that because we want people to use it, and we don't want them to have to type abstract element everywhere just for the sake of not being somewhat confusing. So we decided that we were going to call it element also. So as I said, we were kind of balancing compatibility with existing code, clarity of the code that you're writing, and yet realizing that this is an evolution from existing code that already exists. So what we did is there is a DOM element in the new DOM package, and then the traditional user.client element extends that one, but it doesn't add any methods. So the net effect is that mostly, you don't have to do anything at all, but mostly there are cases where we could overload the type signatures for things like set element and some other methods, where it takes the old one or the new one. So if you're writing widget code that uses either one, it'll work. But then there are a few cases where it got a little clumsy. So UIObject.getElement returns an element of the old type, not the new type. We really want it to be of the new type, but in fact it would break existing code if we did that. So we had to settle for this compromise. But I'm trying to paint it in the bleakest light. It's not actually very confusing in practice, because for one thing, you don't have to do anything at all. It's all backwards compatible, so you can just recompile. You'll still get all the benefits of the compiler optimizations that I've been talking about. It's just you don't get quite the same elegance in the way that it looks. You're still having to use the DOM dot whatever classes. I do suggest if you start making this transition that you do it one full source file at a time. So in other words, the basic problem is that you've just got this type whose simple name is element. But there's really two different things called element that are important to you, and they both need to occur sometimes in the same file. So what happens is you import one so that you use the simple name, but that forces you to use the fully qualified name in the other cases. But in practice, if you do it, you can set it up so that you import the one in the new DOM API package, and you almost never even need to use the other one at all. But if you're going to do that, it's better to do it wholesale for that whole source file and just switch over completely. So then you've got something like UIObject.getElement that returns the old element. But here's the problem. The new element is the superclass of the old element, okay? So I'm going to try to draw this with my hands. Element, the new one, element, the old one. Suppose that your widget has a div element as its primary element. Well, a div element is actually a subclass over here that's a sibling. It's a subclass of the new element and a sibling of the old element, right? Because we wanted the DOM package to be independent of the old user.client stuff. So it's very clean and isolated, and this issue is the only one that comes up, the one I'm describing here. So what happens is you get one of these, but you know you want it to be a div element, right? So there's a really easy answer to this. There's a method on JavaScriptObject called .cast, which lets you cross-cast among any subclass of JavaScriptObject. So in practice, all this comes down to is you say something like getElement.cast. And it'll be really obvious where you need to do this, because you'll have a statement that looks like div element E equals get element, and it'll say, sorry, these two types are incompatible. And you say .cast, and then the compiler shuts up and everything works. There's one other caveat. Memory leaks are still an issue in some modern browsers. I won't name names, but IE. Actually, if I could really remember properly, I think there is another browser that does have some memory leak issues, but it's still true. And as Joel Weber, the father of our UI library, wrote it up, IE7 claims of solving memory leaks are greatly exaggerated. So we want to provide easy event hookup in this nice new DOM API, but the truth is if we did, you would write Java code that creates memory leaks. So it's still true that if you use the widget library of GWT, or really now any Java code in GWT, that you won't leak memory. You'll have to do something extra in order to leak memory. But if you're writing just to the DOM layer and not using widgets, that extra thing that you'll do will be a little bit of JSNI that hooks up some events. And that's where you'll write your leaks. So in general, it's still true that the very best way to utilize these DOM classes is to implement widgets with them. So, extend the widget class or create a new panel and use it as a very elegant way, an efficient way to implement widgets. But if you decide that you're a total, JavaScript and DHTML badass, you can design your own event handling if you want to, but just read Joel's article about how memory leaks occur and how to avoid them and how we solve it in the GWT widget library to make sure that as you dive into that territory that you don't inadvertently create leaks. It's very easy to do accidentally. So this was the surprisingly Rockin part, and I've been pitching my talk here every opportunity I get because I want to talk about JavaScript overlay types. This is one of the most exciting things in GWT 1.5. The DOM classes were basically trivial. It's actually nothing special at all. It's just a teaser to get you to come to the talk. The real news is there's some hot new JavaScript object plumbing, and you've probably already gotten a hint about this in GWT 1.5. So imagine I've got a JavaScript object that comes from the wild. Maybe it's a JSON object, maybe it's an HTML DOM element, maybe it's an XML DOM element that I got back from an XHR request. Imagine I can write a Java type that I can code against, and then at runtime I just overlay that Java type onto the JavaScript object. So it's not that it's a wrapper object, and we intentionally avoid the term wrapper. It isn't a wrapper. It literally merges the type as you see it in Java on top of the JavaScript object that is really there in the browser. I have to get a sanity check here. Does that make sense in general? Yeah, go ahead. Is there a mapping from the JS object back to the Java? There's not. This is a way to import superimpose Java types onto JavaScript objects. And an important aspect of this is that we want it had to be designed so that it doesn't even touch the underlying JavaScript object at all. Okay, this has some interesting implications. As a very practical matter, if you look at the XML DOM as it's implemented in IE, for example, we couldn't touch it even if we wanted to. So normally you've seen expandos in JavaScript. Have you guys seen expandos where you could just attach a new field to any old object you want to? I can take an HTML DOM element and synthesize a new field on it, and it'll remember that. Well, if you try to do that against a node that came from the XML DOM in Internet Explorer, it's a runtime exception. It just doesn't work. Yet, we wanted to provide the same nice programming model on top of XML DOMs. Okay, so how do you do this? You have to ensure that you're not adding any junk to the underlying JavaScript object. We can't record state there. We can't write extra metadata at runtime. We have to truly leave it alone. And what's exciting about overlay types is with a simple set of rules, we can actually achieve that so that you get a nice programming model. You don't mess with the real object at all. And it's very efficient. I think I've already beaten the benefit of the type system to death here. And probably the whole zero overhead thing, I think I've mentioned that before. Now let's look at how you do this. And why I say that the DOM API is trivial is that it is really just a bunch of this. I mean, it took Joel an entire weekend and probably a few beers to get through this, but he just did this exact same mapping for every one of the HTML elements. Okay, let's take a look. So we extend, in this case, it extends element, which itself extends the JavaScript object class. Every method is implemented, in this case, using JSNI, although that need not be the case. But every method does need to be final. Look at some of the craziness that I'm doing here. So let's look at getAlign, okay? I'm directly returning this .align. So this is referring to the JavaScript object that I am overlaying onto, which, in this case, a table row element does have a property called align. So I can write that first method that way. Even crazier, though, is the second method here, getCells. There is a property called cells that does return this thing that is a list. So we modeled that as yet another overlay type that's actually a generic node list overlay type. And all I do is simply return it. And it just works out that each method maps in a fine-grained way onto the right things as you compile it. So you get all this expressiveness and essentially no extra overhead at all. And so on and so forth. I think we need to dig down a little bit more. We'll come back to node lists and emphasize that a bit. But for now, let's look at how you actually can use this. I can say doc.getElement by ID, for example, and that returns an element because when I do getElement by ID, I don't know that it is a div element, right? GetElement by ID could, in theory, return any element type. So I can't be more specific than to say it's an element, and that's what the first statement is. But I know that it had better be a table row because that's the way I'm writing my code in this case. This particular example, by the way, is the extra level of casting is because I'm using getElement by ID. The nature of that particular method does cause you to lose type safety, and then you have to regain it. And what I'm trying to illustrate here with the underlined method call table row element dot as is that's a convenient way to cast between different element types within the DOM. What as does is two things. Actually, I'll show you. The first thing it does is does an assertion that the element that you're trying to cast from is in fact really, it seems to be the kind of thing that you're casting to. So the best you can do really is check the tag name. So it does that as an assertion. So in hosted mode, if you're doing something really stupid, an assertion would fire. And then it does a trust me downcast. In other words, it does a traditional downcast. In this case, it never throws an exception under any circumstances. It never throws class cast exception. We'll come back to why that is in a moment. Is this making sense so far? You're writing the Java code that looks one-to-one like the JavaScript you would have written. Okay. So now, let's think about how you can leverage this for JSON, modeling JSON types within your Java code. This comes up all the time. And I'll be totally honest, the JSON library in GWT 1.5 and down, the one that's called like JSON library, is convoluted. I mean, it by its nature, it has to give you an API that explores the JSON structure, but you can't superimpose what it is. You have to ask for things by a string name and so on. And that's just an inefficient, unnecessarily dynamic way to interact with a JSON structure. In real life, you fetch a JSON object, you know it's a customer record, you know it has a field called first name, you know it has a field called last name. There's no reason to add that extra level of string-based lookup. And that is what we solve here. So let's get a JSON object from the wild. I'm doing it here in JSNI. This is a customer record, or a friend in this case. First name, last name, hobbies, and it's even got a nested array, JavaScript array. All right. First thing to notice is I am constructing a JSON object, just a raw JavaScript object, and I am returning it as a strongly typed friend class. All right, how does that look when I write code against it? I could do things like, f.firstname, f.lastname. I'm calling methods on this friend class that I'll show you in a second. Then when I actually reference the hobbies array, I just directly use it as something called JS array, and it's a generic array that says each item is a string. So again, this is the sort of code that you would write. Other than the parentheses, this is almost what you would write, by hand in JavaScript. Strongly typed and all that stuff. Here's how it actually looks when I implement it. And you can do this yourself with any type you want. Extend JavaScriptObject. As I mentioned, your methods need to be final. And again, I can simply return the various components like first name and last name directly from the JSON objects. And again, I can return an array as this JS array, and it's doing this sort of magic implicit, overlaying. It's overlaying an asserted Java type onto this runtime structure. It really works even for generics. JavaScript does have an array type underneath the covers. And so if I can get one from the wild, I can overlay my array model on top of it. And so I've just defined a generic array here, and it's got a get method and a size method. When you think about the fact that this keyword is referring to the JavaScript array object, it makes sense that you would write it like this. And yet you're providing a nice Java API around it. So is it fast? So here's the actual code that I lifted in pretty mode, unobfuscated mode, from what the compiler produced for this same method. So you can see the JavaScript object there getting assigned to f. The calls f.getFirstName, f.getLastName became the little bits of JSNI that I had handwritten, got totally inlined. The reference to the hobbies array became a simple variable assignment. And then I was able to iterate over the array. I didn't call hs.size, which was the method I wrote in JavaScript and in the Java overlay type, which was implemented in terms of .length, right? It inlined that away so that method call is gone completely now too. In other words, I can't think of a way you could write faster JavaScript than this for this same use case. Actually, I can. This is how you do it. So this is what the compiler actually produces in obfuscated mode, right? Because remember, white space costs you. White space makes your app start slower. Comments makes your app start slower. That's crazy. So get rid of those. All the obfuscatable names are obfuscated. And actually, if you notice what's not obfuscated here, when I say a.firstname, a.lastname, see that on the second line there? I can't obfuscate things that come from the wild. So that's actually a reason that in some cases, GWT can produce much tighter code even than JSON. Because in GWT, it's always a Java object. Those are Java fields that we recognize and can obfuscate. Whereas with JSON, we have to be a little bit more, hands off, and we can't obfuscate last name or first name because that some other bit of JavaScript code that's running on the page might depend on those names. So any identifier that's referenced in a JSNI block, obviously we can't, we treat that as an unknown name and don't try to obfuscate it. Also interesting, this is just a side note, but if you see how we allocate the names of the local variables there, if you notice it's A, B, C, D, E. So when it comes to obfuscation, you want the fewest bytes possible, right? So instead of having an alphabet that you use across the entire script, like start with A and then allocate B, C, and then you run out of characters and you go AA, AB, AC, what you really want is still just use one character. And if you recognize the various different scopes and ensure that you don't you can reuse the same alphabet across different scopes as long as those scopes don't intersect with each other. In other words, we're able to use A, B, C, D, E, etc. in every function that is a disjoint scope. So in the long run, that produces smaller JavaScript, and smaller JavaScript is faster JavaScript. Also, string literals here, if you notice, there was, I think we had said likes and thinking about coding, talking about coding. Those don't appear in this code sample once it's obfuscated. And the reason for that is that on Internet Explorer, every string literal that appears, even if it appears inside a loop, every string literal occurrence acts as an object allocation. So even though it's the exact same string literal, it still allocates more memory, and more to the point, it increments this funky counter in IE, and that counter drives how often garbage collection fires. And so if you do a tight loop that uses the same string literal over and over and over, you're going to thrash the garbage collector, generate all this extra memory usage, even though you're not actually doing anything different through each iteration. The solution to that is you take your string literals, factor them out, put them into well-known global variables, and replace all references to those string literals with a reference to the global that's been interned. And that's just one of the things that Gwt does for you automatically. All the function calls have been inlined, and we removed punctuation and spacing that wasn't needed. Subtle things we're abusing in JavaScript, like the fact that you don't have to end all statements with a semicolon, for example. There are cases where you can save the semicolon. That's 1 byte. Now multiply that across many thousands of lines of code, and you shave, by removing semicolons, you shave 15K off of the app or something like that. So there's all sorts of neat stuff like that in there. And you certainly wouldn't write this by hand in JavaScript. Okay, here are the rules about using overlay types. So you have to extend JavaScriptObject, as I mentioned. It's okay to do it indirectly. You can have multi-level hierarchies, as you saw with the DOM. They have to have an empty, zero-parameter protected constructor. Some of this sounds arbitrary. There are actually reasons for it. But the point is, you can't really instantiate the thing yourself. It's an overlay type. It's not a Java type that's getting allocated. It is overlaying on something that was allocated genuinely in JavaScript from the outside. So consequently, you can't use new at all to create JSO subclasses. You can't have instance fields, which might seem surprising, but it sort of makes sense, because all you're doing is overlaying on top of a JavaScript object. If we were to let you have instance fields, where is the state actually stored for those instance fields? It would have to be stored on the underlying JavaScript object, but as we said before, we can't mess with that underlying JavaScript object, or otherwise things would start breaking for people. So you just can't have declared instance fields. If you need declared instance fields, you can have setters and getters, write those in JSNI, and use the expando capability of JavaScript to generate fields on demand. So it's kind of crazy, but at least you won't go insane, because you do have at least bean-style getters and setters around the abstraction there. Now this is weirder too. All methods must be somehow final to avoid polymorphism. Can anybody think of why that might be? Why could you not use polymorphism in this model? I mean, I've thought about this for like months and months and months, so I wouldn't really expect anybody to have this on the tip of their tongue. Bob. You don't know what the Java type of the underlying JSO would have been. In other words, there's no type information at all. There's no ability to create this indirect vtable kind of polymorphic dispatch table, because that would be modifying the JavaScript object. We can't even store type metadata because there's nowhere to store it. We have no state of our own. It's an overlay type only. In other words, we want this right here, this is an example of a method on an overlay type, to be able to be rewritten as that. And what this has done, I've made this method magically static within the compiler. It rewrites it, and it passes in this object as the first parameter behind the scenes. And it turns out, if polymorphism is available, then there are some cases where the compiler can't devirtualize the call. And if we can't devirtualize the call, it means we have to generate code to do a polymorphic dispatch, which necessarily means extra bookkeeping data on the object, which means we've messed with the object, which means we failed. That's not what overlay types are about. I think since it is such a powerful feature, if used properly, I hope you don't mind that I'm really kind of going into lots of nuts and bolts detail here, because I want you to understand why the limitations are there and that they're there for a good reason, but also so that you use the capability, wisely and don't inadvertently shoot yourself in the foot. I talked about cast before, but let's talk about a little bit more on that. You can definitely blow stuff up with this. And it's almost worse if you're not careful, because you can write like seemingly correct Java code now that maps onto JSNI methods that really doesn't make any sense anymore. In other words, I could overlay my friend data type, my friend class you saw before, onto my rectangle JSON object, right? And I call getFirstName, and I ask a rectangle for its first name, right? That's pretty insane, and that is very easy to do with overlay types if you're not relatively careful about it. So even though Java has a great type system, with this mechanism, we have to trust the programmer. So you have to be careful. Now, I'm painting the bleakest picture so that you'll be careful, but in practice, you'd have to go to some trouble to miscast things. It doesn't, if you use it the way you would expect to and you've implemented your overlay types properly, there's not going to be any big explosions. So the other perhaps surprising result of this logic is for any subclass of JavaScript object X, X is an instance of any other overlay type. There's genuinely no way to distinguish one overlay type from another at runtime because we don't have any place to store bookkeeping data. We basically just trust that if you say it's a duck, it's a duck. And we're going to compile the code as if it's a duck. It also means that casts always succeed. And the Java compiler won't let you cross-cast by default. You can't even make the compiler. If I've got, say, two subclasses of some superclass that are obviously siblings, it's statically illegal to try to cast from this guy to this guy, because that could never work in normal Java. So what we've done is we added JavaScriptObject.cast to get you around that. So basically it's a no-op that is a bullet hole through the Java type system that lets you cast this guy into this guy. Just trust me, it'll work. That's what .cast is all about. So it is crazy, but you know what? This is how programming JavaScript is all the time, right? Like, I think there's a property called firstName. I'm going to write my code assuming that it's there. And if it's not, maybe you'll find that out when your end user reports the bug. But so it's good to think of it as leverage, and you certainly want to write a lot of unit tests around your overlay types to be positive that you're working with the object that you think you are and the way that you think you are. So putting it all together, the demo, I was so eager I had to show you already. The demo was really just the compiler iterations. And so let's wrap up. We're running out of time, and I'd like to do some questions. But so when you go home today or tomorrow and you download 1.5, hopefully you will, don't feel like you have to do anything. And if you do feel the need to do something, please don't do it 2 days before your big launch. Because, it could be a little bit clumsy at first. So that's my advice. We made it backwards compatible so that you're not going to force your hand into making any changes. But you should strongly prefer the new DOM classes. You get clearer, more correct code. You can leverage your IDE more than ever. And I also belabored the point about compiler optimizations because you shouldn't fret about peephole syntactical type considerations in the performance. You can have chains of nested method calls. As long as the methods themselves are really simple one-liners, there's really no cost. It all inlines away. And if you're not sure, compile with -style pretty and take a look at the JavaScript code that's produced, and you'll see what sorts of optimizations are being performed. And that's a very good practice to do anyway if you're trying to optimize your code. And if you're using overlay types heavily, I'm assuming you are trying to optimize your code, so you should also get in the practice of looking at the JavaScript code. It's a good thing. But do fret about actual browser performance, because there is no silver bullet, at least not in Quit yet. There are real implications to having certain kinds of nesting structures among elements and relationships between very complex CSS and the DOM. So just because you don't have to worry about performance at the JavaScript coding level doesn't mean that you can't create elaborate DOM structures that still run like a dog. Okay, so this is not an excuse to not worry about performance. It's just one area that you don't have to worry about performance so that you can reinvest your time into worrying about performance in other ways, like very complex CSS. You've probably seen a trickle of articles lately in Ajaxian and other places talking about the costs of various CSS structures. We want you to be able to spend time trying to figure out how to improve performance in those more subtle areas and not worrying about the low-level code itself. And you should feel free to use overlay types liberally, and you should never fear integration with JavaScript again. If you're trying to decide between, say, GWT and Dojo, for example, try both of them, and if you like both of them, use overlay types to pull the Dojo types in that you like with no extra cost. So we expect that overlay types will be used for an ever greater suite of integration libraries that, again, don't have overhead. And hopefully, one of the points we wanted to really beat into everybody's head this week is that GWT is not slower than handwritten JavaScript. In every test that I've done, especially in the last 6 months, it's typically faster when you're writing a non-trivial amount of code. So you can be more productive and higher performance, and there's no need to apologize for writing in Java. You're the one who gets to go home and have dinner with your family instead of working all night, fighting browser quirks. So anyway, thanks very much. Let's go on and... I do, real quick, want to say a huge thank you to the compiler team and some of our open source contributors. Ray Cromwell, as I mentioned, is doing a great talk, GWT Extreme, coming up. And all this was made possible thanks to some brilliant insights on the part of the people I'm mentioning here. So, if there are any questions, I think we have a few minutes left. Oh, yes, please.
Oh, yes. If I have a performance issue, I don't know if whether it's in the Java or the converted JavaScript. What is the recommended profiler we should use?
Gosh, is it possible to turn up the volume to the floor speakers? Because I couldn't hear it all.
Okay, so if we have a performance issue, we don't know if it's in the Java code or in the JavaScript. Is there any recommended profiler we can use?
Is there a recommended profiler if you have performance issues?
Yeah.
There's a profiler I know for Firefox. I think, is there one in Firebug? Or there was one built into Mozilla at one point. And YSlow is sort of a profiler. But if you want a fine-grained profiler, I don't know of a great solution for that.
I see.
Sadly, at this point, the tools, one of the better things to do is actually just use logging code. Set a timer before and check it after you do some operation.
I see.
Yeah.
Thanks.
Oh, okay. Check with Steve Souders has a book called High Performance Websites. Is that the name of the book? Yeah. And he has a website too that has a lot of references for performance.
Sure. Yeah.
Analysis.
Thank you.
Yes.
In libraries like ext.js, they do things where if you build up a hierarchy, you have divs and you nest your divs, and you can either use the DOM API to create it underneath, or certain browsers it's faster to do inner HTML and build up a string and parse that. Does GWT do any sort of optimization underneath?
So that's hard to do at the compiler level because that's really more of a library kind of issue. I'd say that the area we're working on that relates to that idea is declarative UI. And so that's not in 1.5, but it is pretty likely to be in 1.6 pretty soon. The way declarative UI works is that instead of implementing a widget, for example, using imperative code, right, like the same code you're writing today in GWT, you can instead use a deferred binding code generator to associate a .xml file with that widget. And that .xml file contains an XHTML template that contains a mixture of HTML and references to widget type names. And at compile time, there's a code generator that parses that XHTML. It uses as much of the HTML as it can. It can create long runs of HTML strings. And then it constructs the imperative code automatically that you would have otherwise written by hand. So it takes advantage of the set inner HTML technique for all the HTML that you write, and then it uses widgets to insert the more complex widgetry into the HTML template, And it does all that by generating code that then can be compiled and optimized. So it's a long way of saying, yes, I think we're going to have a facility like that. And if you want to read the design doc, there are references to the way the declarative UI works on the GWT wiki.
Thanks.
Yes?
The Lombardi guys were pretty enthusiastic about GWT, but they found a couple performance issues that I'm wondering if you fixed. One was with the event proliferation with too many event listeners, or the object proliferation, and the other was that the hash tables, using native hash tables when possible.
Right, great. So the first thing is that the JRE collections, just by their design, are heavyweight, and they really rely on polymorphism. There's a limit to how much we can really optimize those. And I have to say that they're definitely better. Hash map is faster. It does a special case for string keys and things like that. But I believe that they're a bit heavyweight for high performance use, honestly. What I want to do in 1.6, or at least as soon as we can, is create a set of lightweight JavaScript collections that have a lot more sort of meager abstractions, but they're a lot higher performance. I mean, at the end of the day, you want a map and a list, right? You don't need a grandiose collections design. So you can use overlay types, as you saw with the JS array, to build those yourself right now, and it's almost trivially easy. Fast string map, for example, we may never have to make that public because you can build it yourself in seriously 45 seconds or so. And so that's really the right answer, is build the structures you want. We'll also work on having a nice reusable collections library that's a whole lot faster. Regarding events and sync events, I have to admit, I don't know if we address the bug about sync events itself getting faster. I do know, though, that this is a bit of a breaking change in 1.5, that now we only call sync events when you actually try to listen for an event. So we used to do it, as Damon said, in the constructor for every widget. And so that was kind of a waste of time, because if you're not actually hooking up a listener, then, so now when you call add click listener, that's when we sync events. So that'll help. I don't remember if the sync events method itself got faster or not.
I know a patch was made for it. I don't know if it actually got released or not.
Okay. I don't know if it is or not, but we'll have to take a look. If not, we certainly need to circle back and get that in there.
Also, do you have JSNI interfaces are you going to for all the sort of like gears and data APIs and all this, everything?
There's a library called the Google API library for GWT, GWT. In fact, unfortunately, my talk is at the same time as the one about that library. But you can go check it out. There's gears bindings, there's maps bindings, and there'll be an AJAX search and an increasing number of bindings for Google APIs over time. But at the same time, it's pretty easy using overlay types to just, you shouldn't wait for us. If you want a binding, you can see how you can whip it out like in just a day, something like that. Yes.
So if I've understood everything correctly, it sounds like there is no reason to ever again do the DOM dot, to use the old DOM class. And so would the plan be to deprecate it?
It depends on how much of a switchover there is to the new DOM API, honestly. And also, it's not quite true that you never have to touch the DOM class. The issue of events is still so sync events instead of event listener. That's one where we believe maybe there's a better event model out there, but it doesn't solve all the problems yet. So consequently, you still have to use it for those methods.
So it sounds like you could deprecate some methods, though.
Yeah, we could do that. We're somewhat conservative about deprecating things, but I would not be surprised if we did choose to deprecate those in a release or two. Yeah. One thing, by the way, that is really deprecated is the use of JavaDoc metadata annotations, type args, and there's some other ones for resource bundles and for image bundles and for messages. Please switch over to using annotations. If you do that, then we can speed up hosted mode by probably an order of magnitude. One of the reasons hosted mode is slow is that we have to parse the Java source code in the process of delivering the bits to you that you can debug. We have to parse it so that we can do the magic to like run the code generators and all that stuff. If we could just use the bytecode, which the annotations do survive into the bytecode, if we just use that, then we could save all that parsing time. Hosted mode will get faster. So do please switch over to annotations, and we'll probably stop supporting the Javadoc metadata in the next release or two. It's a form of tough love, and everybody will be glad, a year from now. So.
Is there a way to turn that off?
What's that?
Is there a way to turn that off?
Turn off the warnings?
No. To tell the hosted mode to stop scanning the source.
Is there a way to? Well, it's really fundamental to the way that it works. It does two things. It parses the source file. Well, it literally compiles. There's a compiling class loader in there. So that as you're running and hosted mode asks for a new class, it literally runs the compiler in line in real time. Not the JS compiler, the bytecode compiler. Generates class files into RAM. And in the process, that's when it rewrites the JSNI blocks, and that's when it parses your Javadoc comments. So there's really no way, until things switch over to being bytecode centric, there's no way to avoid that. Anything else? Any question at all really doesn't have to be about DOM. I think we have another minute or two. Well, have you guys, has anybody looked at 1.5? Can I show you something real quick? This is a new doc reader that we've been working on for the GWT documentation, and so we're going to switch over from the static stuff that you see on Google Code to this more dynamic UI. And we've added a lot of additional information here. So, for example, all the stuff that's new, you can just kind of read through this, and it explains, how you ought to change things. And there's a lot more detail than we've even talked about here at the conference. Some of the other things that we're going to do here, now that it's really easy for us to produce documentation in this form, we added a whole new tutorial, which hopefully can help people get started on the right track. And then the developer guide hasn't changed a whole lot, but you can see now that there's a lot better way for us to surface more useful structured information about best practices and so on. So we intend to leverage this new documentation UI a lot. So if you don't like it, now would be a good time to say. Or if you have feedback, features, or whatever, please say so, because we're planning to kind of double down on this as the way that people will be using Doc. There's already a prototype of gear support for this, and we think it can be really good. There's really good keyboard support, so I can navigate all the Doc without ever touching my mouse on at least in, I think, 9 out of 10 browsers.
Hi, I have a question about using this for creating the JSON representations of plain old Java objects to shove across the pipe between two entities, never dealing with JavaScript at all. But can you visualize a way I can use this to create and maintain these in parallel without separate representations?
Create and maintain JSON objects?
Yeah, the communications between two Java engines running, as a server and a client someplace. And I'm just using this as a pathway between a very light path. And I'm trying to figure out a way to avoid duplication of efforts.
Right. Let's see. Well, you couldn't use the exact same class on the server because typically it would use JSNI, and that's not going to run on the server because that's JavaScript. I could imagine some sort of utility method that took a JavaScript object. Let's suppose you set getters and setters. You created getters and setters for your JSON objects. You could create a create static method on the JavaScript object, and then it would create a blank object. You call all the setters, for example. Now I've got a live JavaScript object that has the state that I want, and I could have a utility method that could serialize that into JSON string, and then I could upload that string using like request builder or as part of an RPC or something like that. Does that make sense?
Yeah, I've used reflection and personal annotations to select specific things that I wanted to end up in that out of an existing class and generate these underlying things so I didn't have to do it duplication. And it seems like it's just going to be a little bit on the slow side. I've been trying to figure out a way to move it out into the compile stage.
That might be one we should talk about, like
Offline?
Yeah, offline or on the group or something like that. But if you'll be around for a few minutes.
I will.
Yeah.
Thank you.
Okay.
Yeah, I have a question about DOM in GWT 1.5. Can you get element by XPath expression?
Can you get an element by XPath expression? No, there's not a built-in library for that right now.
Is it going to support it in the future, or?
Well, honestly, I haven't seen a limited, experience. Everybody's got their own set of things that they've seen. I haven't seen a lot of cases where that's really the best way to write the code. I mean, get element ID is really fast by its nature. XPath is kind of either fast or slow, and it's kind of hard to predict whether it's going to be fast or slow. So it's not clear that that's a style of programming that we would want to encourage. And so I'm eager to go see the GWT Extreme project talk, because Ray has done something along these lines, taking kind of a radical different approach, and I think you'll see his results are really quite interesting. So why don't you come to that talk, and then you can get a feel for where it's going. Okay. Seriously, I think you'll be surprised and happy.
Not a general interest.